Hello, Mr. Geislard here, and we're going to take a look at the fundamental principles of counting and factorials. The fundamental principle of counting comes from the idea that there's going to be times when we want to find out how many different possible ways something can happen based on given information. And the fundamental principle of counting is just kind of a shortcut for finding that total number of possibilities. Let's take a look at this example here. You go to a sandwich restaurant and there are 5 different types of bread, 6 different types of meats, 8 different vegetables, and 4 different types of sausages. How many different sandwich orders can you have if you select one from each category? Well, the way you do this is just by using multiplication. We made what's called a decision chart here. In a decision chart, you will use a blank for each decision that you have to make. In this case, we have to make 4 decisions. We have to decide what kind of bread we want, what kind of meat we want, what kind of veggies, and then what type of sauce we want. So, since there are 5 different types of breads, I'm just going to put the number 5 in my first blank. There's 6 different types of meats, so I'm going to put a 6 there. 8 different types of vegetables, so I'll put an 8 there, and 4 different types of sauce, so I'll put a 4 there. So then you're going to multiply all of those numbers together. And in this case, when you do that, you're going to end up with 960. So if you choose one thing from each category, there's 960 different possible sandwiches. Let's take a look at another example here. In this example, we're going to be looking at license plates. So let's say that a license plate has 3 numbers followed by 3 letters. How many license plates, or how many different license plates can be made if numbers and letters can be repeated? So what we've done is we've set up a decision chart. There's 3 different numbers, so we have 3 blanks there, and 3 different letters, so we have 3 blanks there. So now what we have to do is say, how many different numbers do we have to choose from? Well, if we start by using the number 0, we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count them, there's actually 10 different choices. So there's 10 different digits that can possibly be used. So the first one, I can choose from those 10. Because I can repeat them, I can choose from the 10 again, and then the 10 again. Now with letters, I'm not going to write them all out, but there are 26 letters in the alphabet. So that means if I can repeat, we'll have 26 different letters to choose from each time. When you multiply all of those together, you're going to get something like 1,757,6,000. So 17,576,000 different license plates. Now, what if numbers can and letters can't be repeated? Well, if numbers can be repeated, then again, I'm still going to have 10 in each spot because I'll have 10 digits to choose from. But if numbers or letters can't be repeated, the first one, I'll have 26 letters to choose from. But once I choose one of those, there's only 25 letters left to choose from. And then if I choose another one, then there will only be 24 letters to choose from. So when we multiply all those together, we're going to end up with something like 156,000,000. So we'll end up with something like 15,600 or 15,600,000. And then the last one, what if numbers can't be but letters can be repeated? So now the numbers can't be repeated, so if I start with 10, if I choose one, that will only leave me with 9 left to choose, and then 8. And then if I can repeat the letters, I'll have 26, 26, and 26. So when you multiply all those together, you will get a total of 1,265,4,720, or 12,654,720. Okay, let's look at another example here. It says 8 athletes compete against each other in the 100-meter dash. In how many different orders can they finish? Well, if you have 8 racers, we're going to have 8 different spots, which is why we have 8 different blanks here to choose from. Now, if we look at this, how many different racers could finish first? Well, there's 8 racers in the race, so all 8 of them could possibly finish first. Now, if one of them finishes first, that means that there's only 7 left to finish second, which means there's 6 left to finish third, 5 left to finish fourth, 4 left to finish fifth, 3 left to finish sixth, 2 left to finish seventh, and then 1 left to finish eighth. Now, that might look familiar to you. That's actually a factorial. If we want to look at this, we know that if you take all of the things and arrange a whole group of things, that it becomes a factorial question. So in this case, 8 times 7 times 6 times 4 times 3 times 2 times 1 is 8 factorial, which is 40,320. Again, if you are arranging all of the items in the group, you can just use the factorial. So here's another example. Marcos is selecting classes for next year. He plans to take English, physics, Spanish, government, pre-calculus, and journalism. How many different schedules are possible? So again, we have 6 blanks because there's 6 different classes. So he could have all 6 of those classes first period, but if he has one of them first, then he would have 5 of them second, and then 4, then 3, then 2, then 1. So again, this becomes a factorial question, which is just 6 factorial, which is equal to 720. Now let's take a look at this same example, but with a little twist on it. It says, what if he decided to take some courses in PSEO, and he was only going to be here for 4 periods a day? How many different schedules are possible for those 6 classes during a 4-period day? Well, now we only have 4 decisions to make. We only have 4 classes we're going to choose from, but we still have a total of 6 classes. So that means there are 6 possible classes there, then 5, then 4, then 3. So I would multiply those together, and that would give me 360. Well, this is something that comes up quite a bit in math, where we only want to take part of a group or certain members of a group, and we want to arrange those members. So one way of doing that would be a decision chart, but that's kind of a lot of work, and there should be an easier way of doing it, and there is an easier way of doing that. To do that, we use something called a permutation. So it's just a quick way of doing an ordered arrangement of some members of a group. So a permutation is a way of counting things when you're putting them in a specific order or arrangement, and when you are assigning specific job titles to members of a group. And in the next video, we're going to talk about how that works and how you do that with your calculator. So here's an example of one that would be a permutation. In a class of 30, how many different ways can an elementary school teacher select students to be assigned to the job titles of attendance taker, lunch counter, pencil sharpener, timekeeper, and student of the week? Since each of these are different things, that means we would have 30 people here, then we'd have 29 to choose from, 28 to choose from, 27 to choose from, and then 26. So again, you can just do that, but there's an easier way of doing that in your calculator that we'll talk about in the next video. But in order to do this, we'll say something like we're going to do 30 place 5 or 30 assign 5. That will do that. So if you just multiply all this out in your calculator, you will get something like 171,00720. So 17,100,720.